Hi students, today we can discuss some of the board questions from the chapter metals and non-metals. Okay, first we'll start with the MCQs. The first question, which of the following pairs will give a displacement reaction? So to check whether a displacement reaction will occur or not, we'll check whether the metal is more reactive. So here iron and copper metal, it is not more reactive. So no displacement reaction. Silver and copper. Copper is more reactive than silver, so displacement reaction. Copper and silver, no displacement reaction. Sodium and copper, no copper metal. Okay, no displacement. So only answer is option B. Okay, displacement reaction to occur, the added metal must be more reactive. Okay, next question. An element reacts with oxygen to give a compound with a high melting point. The compound is also soluble in water. So what will be the element? Will be the element likely to be? So it should be uh, an ionic compound. So ionic compounds usually forms by reacting a metal and a non-metal. So carbon is a non-metal, no chance. Silicon another non-metal, no chance. So chance is for iron and calcium only, but we know calcium. The last uh, outer shell contains two electrons, and it is ready to. It is reacting with the oxygen, producing calcium oxide, which is a ionic compound, and we know it is having high melting point. So the answer may be calcium. Option D. Next is which property of metals is used for making bells and strings of musical instruments like sitar? So these are all metallic properties, but sonorousness is the answer. Option C. Aluminum is used for making cooking utensils. Which of the following properties of aluminum are responsible for the same? Good thermal conductivity, of course, it is needed. Good electrical, not required. Ductility, required. High melting point is required one. Okay, so the option given here is thermal is required 1 and 4 is only given here. So option D is the answer here. Even though ductility is also required, that is not given in the option. Okay, so the answer is option D, 1 and D, 1 and 4. Okay, 1 and 4, option D. Now, next question. Which one among the following is an amphoteric oxide? We learned aluminum and zinc oxides are only amphoteric in nature. So the answer is option C, aluminum oxide. Which of the following are not ionic compounds? So for ionic compound, keep in mind metal and non-metal. So here it is metal, non-metal. It is not a metal. So this the is a not an ionic compound. This also carbon, non-metal. So not an ionic compound. But this one it is metal and non-metal. Okay. So the chance is only for 2 and 3. 2 and 3. Option B is the answer here. Okay. Not ionic compounds. Not non-metal and metal and non-metal. Now, next question. The electronic configuration of three elements X, Y, and Z are given 2, 4, 2, 7, and 2, 8, 2, respectively. X, Y, and Z. Okay. Which two elements will combine to form an ionic compound? So keep in mind, for an ionic compound, we want a metal and a non-metal. So we'll find out the metal from this. Out of the three, 2, 4, 2, 7, both no chance for a metal. So Z with the 2, 8, 2, metal. Why? Because last electrons are ready to give out. Metals always wanted to give out electrons. So this is a metal. Z is a metal. Then we want a non-metal. The non-metal should be ready to take in electrons. So in the case, the second one, Y, is ready to take. This is not ready to take and not ready to give out. So that is X is, there is no chance for X. So the answer is Y and Z. Okay, whereas Z is the metal and Y is the non-metal here. So Y and Z, option B is the answer here. Okay. Next question. The process in which a carbonate ore is heated strongly in the absence of oxygen to convert it into metal oxide. So carbonate oxidation or heating. Okay. In the absence also. That is nothing but calcination we learned. Isn't it? Next is silver articles become black or prolonged on prolonged exposure to air. This is due to the formation of it is silver from silver sulfide we learned, isn't it? So the answer is option B, silver sulfide. Next, the thermite reaction is used for joining railway tracks. Which pair of reactants is heated together in this process? We learned it is iron oxide and aluminum powder. No other possibility. Others are not the element, not the compounds which are used. Okay, so the answer is option D. During the electrolytic refining of copper, what substance is placed at the anode? No doubt it is the impure copper, isn't it? So the answer is impure copper block, option D again. Okay. Next, we'll move to the next type of questions, assertion reason type question. And that first one is assertion. It is given when zinc is added to a solution of iron 2 sulfate, ferrous sulfate, a change is observed as the green color of the solution fades. Correct only, isn't it? Zinc is more reactive, so it will displace iron, so the color will be changing, fading, because zinc sulfate is colorless. Okay, here the reason given is zinc is less reactive than iron. That is a wrong statement. Okay, so assertion is true. That means A is true, R is false. Option C. Okay. Next one, copper alloys are used in making musical instruments. Correct only. Copper is sonorous in nature. So both A and R are correct. R are true and R is a correct explanation of A. Option A. Okay. Now next one, magnesium chloride is an ionic compound. Very correct. Metals and non-metals react by mutual, the word mutual can be avoided, okay, by transfer of electrons. That is also correct. So compound formed by transfer of electrons are called ionic compound. Magnesium and chlorine are formed combining like that only by transferring of electrons. So both A and R are true and R is the correct explanation of A. Option A. Next question. Galvanized iron is not used in the containers of acidic food materials. Acidic food materials can react zinc coating to produce a poisonous substance. This is iron is correct and this is also correct. Okay, because zinc reacts with the food particles producing poisonous substances. Galvanization means coating of zinc over iron particle, iron metal, iron instruments or iron pieces, okay, on the surface of iron pieces. That is what is called the galvanization. So A is correct and R is also correct. Both A and R are true and R is the correct explanation of A. Okay. Now the oxides of sulfur and phosphorus are acidic in nature. That is correct because both sulfur and phosphorus are non-metallic oxides are acidic in nature. So the first A is correct and R is given. Metal oxides are basic in nature. Metal oxides are basic in nature. That is correct also. But A is correct, R is correct. But R is not the correct explanation of A. Option B is the answer. Okay. Now assertion reason type questions are given in a different way. Zinc assertion is here, reason is here. Okay. Zinc can easily displace copper on reacting with the solution of copper sulfate. Correct only. Copper is more reactive. No, it is wrong. So A is correct, R is false. A is true, R is false. Okay. Now, next one is hydrogen gas is not evolved when a metal reacts with nitric acid. We learned it is true only, isn't it? Nitric acid is a strong acid agent. That is also correct. So, both A and R are true and R is the correct explanation of A. Okay. Next is highly reactive metals are obtained by electrolytic reduction. Correct only, isn't it? Because we learned while learning the extraction process, right? In the electrolytic reduction, the metal is deposited at the cathode. That is also correct. So, Both A and R are correct, and R is the. But R is not the correct explanation. R is correct only, but R is not. The question here is, assertion is here is highly reactive metals. Why highly reactive metals obtained electron reduction is not given in the reason. So both A and R are true, but R is not the correct explanation of A. Okay. Next one is metals are sonorous. They are generally brittle in the solid state. They break into pieces when hammered. Wrong. Metals are sonorous is a correct statement. So A is true, R is false. Ionic compounds generally have high melting points. Correct only. We learned. Ionic compounds have strong electrostatic forces of attraction between the oppositely charged ions. Okay, so correct explanation. Correct and correct explanation also. So both A and R are true, and R is the correct explanation of A. Okay. Next is aluminum oxide and zinc oxide are amphoteric in nature. Yes, correct only. We learned. Amphoteric nature means that a substance that have both acidic and basic character. Correct. So option A, both A and R are true, and R is the correct explanation of A. Next is the oxides of sulfur and phosphorus are acidic in nature. That's we discussed already. Metal oxides are basic. A is correct, R is false. No, R is also correct, but R is not the correct explanation of A. Both A and R are true, but R is not the correct explanation of A. Metal oxides are basic in nature. That is correct answer, right? Okay, next we'll talk some short questions. Why are highly reactive metals like sodium and potassium kept immersed in kerosene oil? We learned while when we discuss the chapter, isn't it? Answer here it is given. Sodium and potassium are highly reactive metals. They react vigorously with oxygen and moisture present in the air. So to prevent this accidental fire and reaction, they are stored immersed in kerosene oil, which is cut off their contact with air and water. So this is the way to give the answer for that. Okay, they are highly reactive to avoid a reaction between metal and the moisture from the air. Okay. Next, explain the meaning of malleable and ductile. Give an example of a metal that shows each property. Malleability, we know, can be beaten into thin sheets. The property of a metal by which it can be beaten into thin sheets. Example, we know it's gold, aluminium. And ductility means property of a metal by which it can be drawn into thin wires. Okay, example, gold and copper. You can say other examples also. Okay, this is the example given here, only that. What would you observe when zinc metal is added to a solution of iron sulfate? We discussed before, isn't it? Write the chemical equation for that. Here, what you have to be very careful about the word is observe. So the color change should be mentioned very clearly. Okay. So the answer here is given. Zinc is more reactive than iron, so it displaces. Okay. So the pale green, ferrous sulfate is having pale green. The pale green color of ferrous sulfate will be fading. Okay, will fade and eventually becomes colorless. And here it is given a reddish brown. That is actually not. Okay, it is. You can cut that. The answer that is it is not reddish brown. It is not reddish brown. Then it is silverish gray. Okay, silverish gray. Gray is the answer. Okay, silverish gray is the answer here. Silverish gray deposit you can find. Okay. Now equation is given here. Zinc plus FeSO4 gives zinc sulfate plus Fe. To mention the physical state as well. Okay. Then next is which gas is produced when a reactive metal reacts with dilute hydrochloric acid? We know the answer is hydrogen gas. Write the chemical reaction when iron reacts with dilute sulfuric acid. So here answer given is hydrogen gas is produced, and the equation is given here for iron and sulfuric acid, dilute sulfuric acid. Fe plus H2 sulfur gives Fe sulfur plus H2. Okay. Okay, next, show the formation of magnesium oxide by the transfer of electrons. It is showing here. Okay, the picture we learned also. Then why do ionic compounds have high melting point? That also we discussed. So it's due to strong electrostatic force of attraction between the ions. Right. So you can draw the diagram. You can should not forget to write the electronic configuration. Should not try to show the charges. Okay. Yeah, here it is. O is having 2 minus. 2 minus also you should draw here. You can write it is 2 minus here. 2 minus. Okay, 2 minus. You can write because oxygen loses 2 electrons and magnesium loses 2 electrons. So Mg2 plus and O2 minus. Okay, then high melting point we already discussed. Okay. Next question is metal A is used in the thermit process. Metal A is used in the thermit process. The reaction of metal A with Fe2O3 is highly exothermic and is used to join railway tracks. Identify the metal A. We know it is nothing but aluminium. Write the balanced chemical equation. It is given here. It is given also. We learned also, isn't it? Al plus Fe2O3 gives Fe plus. See, it is written L in the bracket. That should not be forgot. Okay, it should be remembered very clearly. It should be in the liquid form. Then what is the use of the molten product formed? That also we learned. Since the iron is available in the form of a liquid or in the molten form, we can direct. See the answer given here is the molten iron produced in the reaction is poured into the gap between the railway tracks, which joins the tracks together. So that is the big advantage of that process. Okay, we are getting the iron in the molten form. Okay, so the answer is clearly given here. Now state 2 different methods for the prevention of rusting of iron. For each method, explain the underlying principle. So you can write by painting or anything you can write. It is given here. It is galvanization. Galvanization is a process by which we are coating a layer of zinc metal. So what we are doing is we are coating a more reactive metal, so which will corrode first. It will be acting as a sacrificial metal and preferentially corrodes itself. Then iron gets corroded. So iron will be safe over there. And the next process given here is alloying. That means we are making, for example, it is given stainless steel. Iron is mixed with elements like nickel or chromium to form stainless steel. What is special about that? This makes iron chemically unreactive and highly resistant to corrosion and rusting. Okay. So that is good answers are given here. You can write, of course, painting, oiling and all you can write, but this is supposed to be the best answer, right? Now, one 5 marks question. It is describe the various steps involved in the extraction of metals from their ores, especially focusing on metals of medium reactivity. Include the necessary chemical equations. It's a 5 marks question, so keep in mind. Okay, first step is concentration of ore, and we'll explain what is concentration. Okay, then the process of removing gangue from the ore, that process is called and we can use hydraulic washing or flotation. Then you can write conversion. So since it is given medium reactivity, we can write sulfide ore. If it is sulfide, we'll do roasting. If it is carbonate, we'll be doing calcination, roasting, and calcination results in the formation of zinc oxide. So for second step, conversion into oxide. Then the third step is reduction to metal. Then metal oxide, once we get the metal oxide, it is then reduced by heating with a reducing agent like carbon or a more reactive metal. Okay, here it is showing carbon. So reduction is the third step, and the last step is purification or refining the impure metal by electrolytic method. Okay, these are the steps involved. Then the next question. Show the formation of a compound NaCl by the transfer of electrons. Explain the process of electrolytic refining of copper. Draw a neat label diagram of the setup and list the chemical reactions at the electrodes. Okay, so it is given the answer for the first question, formation of NaCl. We are writing the electronic configuration, then we are drawing the picture like this. And we are showing the electron transfer. Okay. Then the second part is process of electrolytic refining. That also you can draw the diagram like this. You can explain each and every point: anode, cathode, electrolyte, reaction. Okay, reaction at the anode and at the cathode. At the anode it is copper is forming copper ions, and at the cathode copper ions are gain electrons getting pure copper. Okay. Observation, they are asking the observation. It is a pure metal deposited at the cathode. Soluble impurities dissolved in the electrolyte. Insoluble impurities settle down at the bottom, and we call it anode mud. Okay. Then next question, why is zinc considered more reactive than copper? Give an experiment or observation to prove this. Give reasons for the following observation.